Okay, so what is the difference between a physical and a chemical change? Physical, of course, it is the same substance. So no new substances are created. A chemical change, you get a new substance or substances created. And with chemical change, we're looking for those specific signs we taught you. We taught you this acronym: city, girls, love, their, cell, phones, on. So this is part of that dumping that we want you to do on your STAR test. As soon as you get it, write down this acronym. And then remember, the C stands for chemical. The G stands for gas production or bubbles. L is for light. T is for a temperature change. C is for color change. P is for precipitate. And O is for odor. And you're looking for those signs. And remember, the key to those guys is that they have to be unexpected. You're looking for those unexpected changes, not something that's expected. Okay, read the comic strip. What kind of change did Calvin's toast go through? Want to see something weird? Watch. You put the bread in the slot, push it down, and in a few minutes it pops up. The toast pops up. Whoa, where does the bread go? Beats me. Isn't it weird? Well, obviously, the bread went in. When it came out, it was a different color, so we had a color change. If any of you have ever toasted bread, you know that there's also an odor. You can smell that toast being, that bread being toasted. And so those two, and they're unexpected. You wouldn't expect to put something in a metal box and all of a sudden have it change colors and smell that way. So that's going to be unexpected changes, which is going to lead us to a chemical change. Okay, the following has some evidences of chemical change. It can be a P for physical, a C for chemical, or we're going to put both, a B for both. It can be either one. A rip, if we rip something, that is always going to be physical. You're just tearing it into two pieces, making it two smaller pieces of the same thing. Bubbles could be either, because if we have the bubbles from an unexpected, we put two powders together, add a liquid, all of a sudden bubbles come out. We would expect that. That would be chemical. But if we put soap in water and stir it up, we're going to get bubbles, which is physical. So this one can actually be both. Smoke. Smoke is going to be coming from fire. It's going to be burning something. So smoke is always going to be a sign of a chemical reaction. Unexpected color change. Here we have that keyword unexpected, which is leading us to chemical, broken down by enzymes. Enzymes are chemicals inside your body that break down the food that comes into your body, and that is always going to be a chemical change. Evaporate. When something evaporates, it just goes from a liquid to a gas. It's still the same substance, so it's going to be physical. A temperature decrease. This does not say unexpected here, so if I put something in the freezer, it's going to decrease in temperature. It doesn't change what it is. But if I add two room temperature liquids together and I get a colder liquid, that is unexpected. So this one can actually be both. It depends on what's creating the temperature decrease. Production of heat. Again, I don't see unexpected here. Production, if we're producing heat, if we're making heat from nothing, not adding heat to it, then that is going to be a chemical change. A new substance, that is in the definition of chemical change, definitely chemical. Solidified, if something solidifies, it is still the same substance, like putting water in a freezer, it's going to become ice. It is going to solidify, and that is not chemical, that is physical. Swallowing, you're just moving it from one location to another, you're not changing what it is. Breaking, it's a lot like ripping, it is just making it smaller. Dissolving, you just take one substance and dissolve it in another, then you still have two separate substances there. Dissolving is definitely physical, not chemical. A gas produced, here's that word production again. If we produce a gas, then it's going to be a chemical change, just like the production of heat was chemical. Now bubbles, not the same thing as gas production. Odor, an odor change, that's going to be, that's chemical, that's one of our letters up there in our acronym. Churn, if we're churning something, we're just stirring it, we're not changing what it is, so that is going to be physical. Absorbing, we take a sponge, we absorb water, it's still water, it's still a sponge, so that's just physical. Precipitate. Precipitate is one of our signs of a chemical reaction. It's the P in our acronym, and it's the formation of a solid through two liquids, like when you have milk that goes bad, and that is definitely a chemical change. Melting, you're just going from a solid to a liquid. You're not changing the substance, so it is physical. A temperature increase, we're missing that word unexpected, so a temperature increase could be both. It depends. If you put something on a stove and it increases in temperature, well, that's physical. You added heat to it. But if it increases spontaneously without the addition of any heat, then that's going to be a sign of a chemical reaction. Fizzing. Fizzing is another one of those that could be both, depending on what causes the fizzing. Just like the production of gas, if it's two liquids that don't have any sort of carbonation in them, then you might get expect a chemical change. If you pour a soda into ice, you're going to get fizzing, but you're just releasing the carbon dioxide that was already in the carbonation that was already in the soda.
Okay, guys, so now we're seeing about which changes occur in the digestive system. So we're going to start at the very beginning in the mouth. So the chewing part, that just breaks the food into smaller pieces. That part is going to be physical. There is another part of it which occurs towards the back of the mouth, and that is the saliva part. Saliva is an enzyme. It's called amylase, A-M-Y-L-A-S-E. That part right there breaks down the carbohydrates. So if you just put like a cracker in your mouth and leave it there and don't chew or do anything, it's going to break it down for sure. Then once we swallow, it goes down into the esophagus. And the esophagus, basically, its job is to squeeze the food all the way down to your stomach. That is called peristalsis. It's a big fancy word again. And it basically just squeezes the food down into your stomach. So squeezing, if you squeeze someone, you don't change them and create them into a new substance, so that therefore is physical. Once it goes down into your esophagus and enters into your stomach, this one has two steps as well. This one, first of all, the churning. Your stomach churns and mashes it up, kind of like churning butter. It just kind of mashes it up into a different, and just mashes it up. The churning part is going to be physical. However, the stomach acids is a chemical part as well. So you've got two things happening. The churning, squeezing of the food, just helps it in the digestion. And then last, this is the small intestine, and this is where actually most digestion takes place, in the small intestine. There are really strong enzymes in your small intestine. This is where the hard to break down food, like your beef, your steaks, your fats, get broken down in your small intestines. And a lot of people think it's the stomach that does the most of the digestion, but it is truly the small intestine. So because of that, it is an enzyme and it is a chemical change. Okay, what is the law of conservation of mass? It states that matter can neither be created nor can it be destroyed. So in a chemical reaction, whatever you start, the mass of the reactants that you start with, and remember, guys, this side is the reactants. We would say RAP, so that stands for reactant, arrow, and product. Please remember that. So this side is going to equal this side, is basically what that is saying. Even when the matter is transformed, the mass is always going to remain constant. So here we have, the way we can see this is two different ways. I'm going to count the atoms on here first. So here, C is carbon, O is oxygen, and hydrogen. I do have another oxygen right here. However, because I already have oxygen listed, I need to go ahead and just do it once and then add those two together. So here I've got one carbon, and I have 1 oxygen, but over here I also have 1 oxygen, so I've got a total of 2 oxygens. And right here, this subscript has 2 hydrogens for a total of 5 total atoms. So that's 2, 3, 4, 5. Perfect. All right, that means that this side over here needs to do the same. So I'm going to put those in the same exact order. It's always best to put them in the same order so you can see them side by side. I've got 1 carbon here. I've got 2 oxygens, that's that coefficient, and I've got 2 hydrogens right here. So I've got 1, 1 and 1, okay, 2 and 2, 2 and 2, with a total of 5 on each of these. So what this is saying is that this is a valid chemical reaction that does follow the law of conservation of mass. If I, for whatever reason, had this, maybe this one was 3 and this one was, that would be 3, 4, 5, 6, 7, 8, 3, 4, 5, 6. So that would be a total of 6, but that one would still be 1 and that one would still be 2. And this one over here had, oh wait, if this one was 1, that one was 1, and that one's 3. I still have 5 here, but if these do not match, this one matches, this one does not, and this one does not. Even though these still two match, it would be wrong, okay? They have to be 1 and 1, 2 and 2, 2 and 2 on the blue side. So in order for it to have the conservation of mass, because I have somehow, if they don't match, I've either created or destroyed new matter. And that cannot happen. So this one does follow the law of conservation of mass. Because it does, this part right here is a different part, and a lot of you guys got this wrong on the benchmark. So I'm going to add these two numbers together. I've got 15 grams and 32, so that's a total of 47 grams on this side. That means that I have to equal 47 grams on this side. So 20 plus what equals 47? So 20 plus 27 equals 47. So that means that I have 27 grams of H2 because they match. All right, so it says in accordance with the law of conservation of mass, how many grams of hydrogen is produced? So back up at the top where we came up with 27 grams. Again, this is a whole number, so it needs to be right here. If you put it on this side, it will be wrong. Many of y'all, again, got the correct answer, but gridded it wrong. Don't let that happen. So right here, where it says potential energy is stored energy. And what are the types of potential energy? So potential energy is stored energy. Types of potential energy, there is elastic, gravitational. So for elastic, think of like a bow or a rubber band. The more you pull it, the more potential energy it has, the further it's going to go once you release that, and that turns into kinetic energy. Gravitational, the higher you are, the more potential energy you have versus if you're lower. So, and then chemical, like gasoline, it has a lot of, or batteries, those have their stored energy and can be released through once that is activated. And so this is a part where you need to take your next mini assessment again and give it to your teacher so that they can score it, and you can write your percentage there.